Okay, so I hope you have heard the lady said recording is in progress. Okay, so guys, you can always expect that re-logging to happen. It's just to inform us on time, and we are now entering the final phase of everything. Okay, so just a few more minutes. All right, I think we will start. The rest might join or took bathroom break, so they will come back and they will catch up where we want to catch up with. Okay, so we stopped off by looking at K. Also note that we explained last time that a vector can have a representation of a small letter, right? But a matrix has a representation of a capitalized letter, all right? And that is also one thing that we differentiate between a vector and a matrix, okay? So with vectors, you will either have them in this form, A, B, with the arrow on top, but in matrices, we will never put arrows on top there, okay? Because matrices does not always only include size and direction. It may include many other things as well. So that's why we don't represent the directions of matrices like that. But it has identities and all those other things that we will be also talking about. So just remember the difference, okay? Vector, small letter, matrix, capital letter, okay? So even if it's the same 2 by 2, not 2 by 2, 2 by 1 vector that we have over here, and we put it as a matrix now, then you must refer to it as a matrix, okay? So capital letters represents our matrices. All right, so I hope that also clears out what you will see. So for most of the matrices, any matrix that I will be identifying, I will start with a capitalized letter, and then I will equals to, and after I equals to, I will put in my rectangular brackets, right? So all matrices must have that rectangular brackets that we are having there, okay? And now based on this matrix, the positions of the numbers and how we line them up is important. So you also have to line them up correctly. If you cannot just, for example, you cannot just start like saying 3, 2, 1, 7, 8, 9, and here you put 4, 3, and 1, 2, 1, 4. So this is not a matrix, even though there's brackets, there's K, and there's numbers in there. I don't know what dimension is this, how many rows and how many columns. Okay, I can see rows are 1, 2, 3, but how many columns do I see now? I see 1, that one is clearly identified. Here, there's a space. I don't know what that space is there. So I don't know if that is a column. Is this 21 or is it a 2 and a 1? So we cannot just write in numbers randomly. Okay, so this will be marked wrong. Even if all the numbers are correct based on numbers that we give you somewhere. But if we cannot identify the matrix correctly, this is not a matrix. This is just grade 1 writing numbers in a rectangle. So it's wrong. Okay. So what is important for us to note is that all our numbers and must follow either in a row or in a column format. So if you put in numbers, you must put them in a row. So over here, I have A11. Okay, so A is just an algebra variable representing any number that we can put in there. A, any number. A, any number. Okay, any number. And this number is positioned in row 1, column 1. Okay, so we position that number in the first row. That is that's the one over here. Tells us it's in row 1. This number tells us it's in column 1. So you can see that this is my row 1 and this is my column 1. So this is R1, this is C1.
Okay, so I reduce rows to R1 and C1. So all the numbers that you will see in next to a matrix over there, this is what we call the position of that variable, of that number. Okay, the position is in row 1, column 1. So you will see later on, we will ask you a question like, okay, find what is the value of the number that is in position R3, C2, okay? Or what number is there? If I say B or is in 3 at the bottom and 2 here, not 32, row 3, column 2. Then you have to go to row 3 and column 2, where the 2 meet. That is the number that I want from you. So that is also one way we can identify elements within a vector. Okay, so if we ask you multiply, I give you a matrix and I say multiply 5 times B3 2. That means whatever number is in column 3, row 2, row 3, column 2, that is what we want you to multiply by 5. Okay, so I hope that makes sense. We will proceed. So this number then is still in the first column. Let me just change the red. It's still in the first column, okay? This is still our column 1, okay? So this number is still in the first column. That's why you see there's a 1 here and then there's a 1 here. So the column does not change, okay? The columns does not change, so it's still there. But since this was our row 1, this was R1, this is now not row 1 anymore. This is R2. So this becomes R2. I'm just writing in extra things here to see. So that's why you see for row 1, there was a 1 for the rows. But for row 2, we have a number 2 for row 2. So the first number always tells us the row. The second number always tells us the column. Okay, so we just say A because we don't know what number is in there. All right, so later on during some examples that we will show you, I will ask you the questions that I said. Okay, find the number which is in row 4, column 3, and then you have to tell me what that number is. So you have to use your eyes to go to the rows and to the columns as such. Okay, so let's proceed to the next one. We can continue like this forever and until we get to m number of rows. So if I go down, my rows are increasing. My columns will always just stay 1, 1, 1, 1. I'm not going in other columns. That's why the ones will always be there. But the row numbers are changing. That's why we have it now called M, okay? The number, we don't know what the number is. We can put in any numbers there. So you can have a very big matrix continuing until M. We don't know what M is, okay? M number of rows in column 1, right? So then after this, we can now go to the second column. So for our second column, which is this one, this is now column 2, okay? This is C1. This will be C2, column 2. And you will see now in column 2, our row is still 1. Okay, we are still in the first row, but the column has changed. So the position is now at 2, all right? And that is now where we are referring to now the positions. We will talk about positions a lot. So this number is located in row 1, column 2, and that is where we are there as well. This is almost like a file system that you will have in offices where you put first surnames in this place, second surnames, and you go on like that. Maybe your surname starts with A, Da, or something like that. And then you go Abba, Abner, and then you go until you get to AZ. Then you start with B's, okay? B's is now BA, Bob, Bob, all those things. Next one will be BC and so forth until you get to where you finish that whole B's, and then we can continue like that. So I'm also just bringing in file systems that we use matrices for file systems in office work or wherever we do, just to arrange things in an order. So if I'm looking for a specific patient or client's document, I just check, oh, the surname is this. Then I know that, oh, in my file system, that surname is starting with a KA, Kachairwa or something like that, then I know I need to go to column K, and then from column K, Kachairwa, okay, it will be for row 1, because row 1s will have the letter A's in it. So that's how I could quickly locate those files. And this is what they use in all the places where work is located. Okay, so we can do the same thing like that for column 2. The 2's will remain, but we can continue. The rows can increase until the rows goes on forever, right? So then we have M, and but M is the number of rows that we're increasing it by, and we are still in column 2. And so we can do it for column 3, column 4, and then we can come until we see that, okay, the columns are now the only ones that are going to be increasing. So we can say, okay, we go continue until column N. N is now the number of columns that, let's say, our matrix has. We don't know what is the total number of columns that we have, okay? So then we can go down the rows again. This will be row 1 with the n number of columns, row 2 with the n number of columns, and we can continue like that until we reach where M and N meet. Okay, so then you have M number of rows and N number of columns. All right. So this AMN, okay, just to explain it a little bit more better. We know that A is just a number. Okay, this refers to our number. Okay, now I said number, but in the previous examples, I said it can also be our file. Okay, the file that you are storing, somebody's medical file or somebody's academic record, or your report cards, or whatever we use to store, that is yours. Its location is now this M and N, where M is our rows, okay, and N is our columns, okay. So in row M, column N, then I know specifically where your number or where your file is located. I just quickly go to that place and I get your thing. Okay, it makes searching easier. If we are having a lot of documents, a lot of files, a lot of numbers, getting that specific number of file becomes easier with a matrix. Okay, and that is one of the useful things of it as well. Okay, so over here, you can see now the numbers A, I, and J. Now we are going back to I and J again. And remember, I spoke about I and I spoke about J, all right? That is your X value and your Y value, all right? X, now you can see again our X value, and this is our Y value, because we are replacing the M and the N with an I and a J. So this is also how sometimes you get confused. In some textbooks, they talk about I and J. In other textbooks or on YouTube, they talk about M and N. And then on a Cartesian plane, we will talk about X and Y. And this is now also what we need to be aware of, all right? So whether it's X, I, or M, that will be our rows, okay? And whether it's J, Y, or N, that will be our columns. That's the only thing we need to be also clear on, right? So the numbers A, I, J are called elements. So this, like we did in what we call sets, we call them now elements. So these are elements that are in these positions, right? So A11, that is element in this, that is belongs to K, okay? So A11 is an element of K, and so forth until we get all of those ones. All of them are elements of K, okay? And so sets are also coming back here as well. So the matrix therefore consists of Mn elements, and it's called an M by N matrix. So a matrix that has this M number of elements, your rows and your columns, right? Elements, it is called a row by column matrix, okay? So there's that M and N. You just check always your row, okay? And then you just put the X there for the by, and we put our columns over there. So I'm just using 3-letter abbreviations for column because that makes it simpler to understand. So we call it a row by column matrix, okay? And that is how we will find our dimension, our size, and our order, or our order, whichever one we ask you. If we say, what is the size of this matrix? Then I want the row by column. What is the order of the matrix? The same answer, row by column. What is the dimension of the matrix? Row by column. Now, the differences between dimension, size, and order. If this, let's say we had a 4 by 3, okay? So if it's a 4 by 3 matrix, then the dimension will be 4 by 3, okay? So the dimensions is just basically telling us rows and columns, things like that. It will be a little bit different. Instead of using 4 by 4, let's use a 1 by 1, a 2 by 2, and a 3 by 3. Okay, so a 1 by 1 in geometry, this is either just represented by a dot. Okay, so it's represented by a dot or either a line, but mostly just a dot. Okay, so one row, one column. That dot or point that we are calling it. Okay, that is just one point or something like that. One X value, one Y value. That's just the point. Then a 2 by 2, 2 X values, 2 Y values, or things like that. This becomes now a line. Okay, this becomes a line. So you now see the line is normally referred to as a 2D. Okay, 2D shape. This is referred to as a 1D shape. And when it comes to a 3 by 3, then this becomes now either those cubes. This line can also be a square or some of the shapes that we have. Now this 3 by 3 becomes now our cubes, our all those other crazy things that we are having. Okay, and this is what we call a 3D. So this D's that you will see in most of the things, they refer to the dimension over here. Okay, all the D's are dimension: 1 dimension, 2 dimension, 3 dimension. Okay, and in matrix representation, a 1 dimension is just 1 row, 1 column. Okay, that means this is just the 1 dimension. A 2 dimension will be 2 rows, 2 columns, or something like that. It could be also 2 rows, 1 column. It doesn't matter how it looks like. If it's 2 rows and 1 column, it's a line. If it's 2 rows and 2 columns, then it becomes a shape, a 2D shape: square, rectangle, triangles. Those are the ones that we are now looking at in this way. And 3 dimensions, 3 by 3s, that's how it will go on in that fashion. Okay, so I hope I've also explained that. I remember last time I didn't go too deep into the explanations like that, but it's always good to understand why are the things called this way. Okay, and then a matrix having m rows and m column is called a matrix order, mn, or matrix size, mn, or the dimension, as I've talked before. So over here we have a small activity after talking so much, which I hope you guys can also answer. It says, if a matrix has a total of 9 elements, what are the possible orders? Now you can see now we are looking at possible orders it can have. So I'm expecting answers of you. Let's say there are 9 elements in that matrix. If you have a pen and paper, you can try and write this one down as well. So I would like you guys to give me the dimensions that can fit 9 elements in it. Okay, so is the question clear, or should I explain using an example?
So it's a 3 by 3.
Okay, so how did you get to the 3 by 3?
3 rows and 3 columns will give you 9 elements.
Okay, so you are having a 3 by 3, all right? So you're saying 3 rows and 3 columns will give me 9 elements.
Yes.
Okay, that is one answer. So he's saying that you will have A, B, C, and then you'll have D, E, F, and then you'll have G, H, and I. All right, that will be my 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. And if you count the elements, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's one way. Anybody else with another answer? Because that's not the only way. That's just one way. Who gave the answer? Who gave this answer? It sounded like Michael, or was it Jay? Okay. Okay, I see it was you. So this is correct. You can fit 9 elements into this. There is another one that we can also, it's not the only one. Anybody to try the other ones? Okay, because of time, I would, everybody is very quiet. Let's just give the answers then. So, yes, thank you, Meke. That is correct. So with Meke, she's saying it's a 1 by 9. Okay, so 1, remember 1 is the row. So that means we will only have 1 row. And in that 1 row, we will have 9 columns. So it will be A, B, C, D, E, F, G, H, I. So all of them in 1 row. That is also correct. So having all of them in 1 row, it's still a matrix with just 1 row, but the columns are now where the different letters are placed. And we can also have 1 column, okay, and 9 rows. So we can have a 9 by 1, okay? So then we will have A, B, C, and it goes on like this until we get to I, okay? So that is also what we can have. So we can represent this 9 elements in a 3 by 3, 1 by 9, or 9 by 1. So this is also important for us to notice, all right? And that already brings our understanding of matrices to a very good point. Okay, so this is just a summary of what we can have. And you will now also notice something very important, right? If we look at the elements here, all right, if we look at the elements here, and we say that we have 9 elements in that matrix. Now you see the way I order the matrix over here. Is it not true that 3 times 3, is this not equals to 9? Yes. Is it also not possible that 1 times 9, this is also equals to 9? And is it also not possible to say that 9 times 1, this is also equals to 9? So now you can see a pattern, all right? A pattern is appearing here. If we say our rows by our columns and we multiply those 2 numbers together, we actually get the number of elements in our matrix. So if we ask you how many elements are in this crazy matrix, sorry, I don't turn the board, I got too excited. If we ask you how many elements are in a crazy matrix that we show you, instead of you counting the elements 1 by 1 by 1 by 1 by 1, and then somewhere along the line you miss 1, you can just say, okay, how many rows do I have? How many columns do I have? Multiply them together. That is the elements that I have for that given matrix. Okay, so I hope that one also important. Now remember, Mr. Kwa is one of those teachers where my learners always ask me, what does mathematics, this thing has to do with my life? And this is also where we bring it in, okay? So matrices help. Why matrices? They help with simultaneous equations. And this is one of those things we will look at later on. So over here, we have a simultaneous equation. And remember, this simultaneous equation can be rewritten as I, okay, plus j equals to 7. And then we have 3i, okay, minus j equals to 5. All right, remember that the i's and the j's is just variables that we are replacing for the x and the y's. right? So if you have a simultaneous equation like that, we can represent it in a matrix form, okay? It's easy to find or show that x equals to 3 and y equals to 4 in this case because of the 7. There's only 2 numbers when you add them, or not so many numbers when you add them to give you a 7, right? And that's 3 and 4, or 1 and 6, or 5 and 2, and you can quickly solve it yourself, right? And that's one way of looking at it. You can solve it quickly. But if you get now a matrix like this, x plus y minus 2z equals to 7, then you will now not be able to find that quickly just by eliminating. Okay, let's put 1 here, 1, 1. Okay, 3 times 1 minus what will give me 5? 2. Okay, so 1 plus 2 is it 7? No. Okay, I cannot do elimination process here. Okay, and if we increase the matrix to this complicated dimensions, all right, this is a 2 by 2 most of the time, and this becomes now a 3-dimensional matrix. We have x, y, and z that we have to consider, and then here you get lost. Okay, so this is just one way of also showing you is that once you get to this point and we ask you to solve it, then you will be lost if you don't know your matrices. So matrices will help us solve these complicated things, and that is basically what we want you to achieve and so forth. So for this year, we will only focus on simple ones like this. University level, they will add another one over there. Okay, they will add the z's and the ijk's. They will add the k's if it's not the z's. So that is just the difference that you also have to consider going forward. Okay. So how much time do I have? Okay, I still have a few minutes left. So let me just quickly open up a quick activity that I would be sharing with you guys, and that will be for activity 1. Okay, I'm just looking for the activity that I will be giving to you regarding the matrices. I had it open, but now it seems to be disappeared. Let me just quickly see here. So the activities are just there to basically test our understanding of what we are currently working on, and okay, so it's this. I just want to quickly open it up so that we know. Okay, here it is. Okay, so I will be putting up this activity for you guys to see. So this is just a worksheet 1, and you can see it's just basically talking about what we have covered so far, and I think that will be basically more or less the end of the lesson today. So we give you a matrix P, which is this one over here, and we ask you to find A, P, 1, 2. Okay, find the elements that are in those positions over there, and we just want to know if you can do that. We can try the first one because it should be relatively easy for us. Then I will explain the rest of the questions, and then you can give it a go. I will call names randomly so that we can at least see if you can find those elements. Please forgive me. Let's start with Felicia. Find for us a P12. Okay, what is that element in that position, Valisha. You can type or you can unmute and just quickly talk to us. So Valisha is for A, Meke will be for B, Giovanni will be for C, and Napume will be for D. Jay, you already answered one, so that would be a little bit late. I didn't call Osha, so Osha, you are safe for now. So let's get the answer. Valisha, please answer. We don't have a lot of time, so at least so that I know you are on the right track. It's just also for me to confirm we're paying attention. So I had Valisha, I had Meke, I had Giovanni, and I had Napume. And Rishwa, you also gave an answer earlier, so you are safe. Just what is the element in that position? So you, A, Valisha, you can say A, what is the answer? Meke, B, what is the answer? Giovanni, C, what is the answer? And Napume, D, what is the answer? If you want to type. So Meke is saying your answer is 100. Meke, I do not agree. Okay. But thank you for attempting. You have another chance again. Okay, so Meke change the answer to 32. And I'll just put it also here so that we can see what's happening there, okay? So Meke change the answer to 32. So if that was your answer, I would have given your answer 32, correct? Okay, I suppose put red pen. Okay, for Meke, I will give your final answer correct. Napume, you are saying is it minus 89? Napu is D, which is 25, and minus 89, that is correct. Giovanni is saying minus 6. This is Giovanni over here, 33. And
I
I'll
think
also
A
give.
is -9.
Come again?
So I think A is -9.
A is -9. I think you must think again. Osha, you can help Valisha. Or Valisha, you can try again. I said just rethink on the -9. The -9 is in this position over here. I think that's the only -9 I see. But I don't agree with that -9. Is there anybody who can type what is the position of -9 in the chat so that maybe Valisha can see?
7.
Rishiwa is saying 7. I don't know. 7 is also not the answer. Okay, so these two answers are wrong. Okay, if you look at this one is your R1. This is your R2. So if you look at the numbers here at the bottom, the first number is always telling us our R. Okay, so if you're looking at your R,
Okay.
now both of you are in the second one, R2, but we are supposed to be in R1. So that is where I say a little bit the error is. So for those who are typing in the answers, yes, the correct answer is 19 because it's in the first row, that is your first number over here, and the second column. So R1 is this one, that is your first row, and this is column 1, column 2. So we want C2 and we want R1. So that is just the position that we have with that regard. So guys, you can see that it's not to say that we are making things wrong or correct. It's just activities to help you understand what have we been doing the whole time. Okay, so and we basically are trying to get you to also understand all those various points that we have over here. So over here, we have another activities that we have. Here, we just want you to find the dimensions or order or size of the matrices that we have given to you here. And you can try and attempt it as well. And then here we just have some questions regarding matrices. A matrix is a what. If you can fill out that missing words from a matrix. And over here, we are giving you another one that we have. I will just say if A equals to this matrix, B equals to this matrix, C equals to this matrix, and so forth. State the order of matrix A. In the matrix A, write down the element. You can see now I'm talking about R and C's. Write down the element A 23. Okay, we are now still talking about write down the element A23, and we're still talking about the first matrix and so forth. Which of the above matrices are diagonal matrix? This is an additional question, okay, that you can just try to figure out for yourself. Given the example of a 3 by 3 zero matrix, give an example of a 3 by 3 zero matrix. Let's just write down a 3 by 3 zero matrix. Write down the elements of the leading diagonal sorry, this question is incomplete here. Okay, this question is incomplete. Let me just edit in here as well. And this we will say E. Sorry about that. This was not complete. I'll just rectify that, and when I upload it, we will have the correct one. Give an example of a 1 by 3 matrix. Okay, so some of the questions you will have to write it in your cell if it's not available there. Okay, for example, this give examples matrices, you have to write it in. Give an example of a row and a column, row and of a column matrix. Okay, just give an example of a row and a column matrix. It's also just to see, do you understand the basics? Now, again, as we said, because we will have to continue tomorrow, and most of these questions that we have there, if we don't attempt them, when we come back tomorrow and we talk about some of these things again, because we will have to continue, if you remember from our table of contents in the beginning, we talked about these are the things that we need to cover for this topic. And the first part was just identifying. We still have to do calculations. So if we don't understand the first part, when it comes to calculations, it will be a big problem, and a lot of us won't understand. All right. So I will upload the homework for you guys, and tomorrow we can quickly go through the homework together, and then we can proceed with the next lesson. So again, tomorrow, same time, 2 o'clock, until we have 2 lessons to 2:30, and then we will continue, guys. So please have a go at it. You can download the page and even upload the answers so that we can at least work through them, or I can see them tonight as well. And that way we solve a lot of problems. So thank you guys for joining. I have another class with the grade 9s up next. See each other tomorrow again.